Welcome or welcome back to 3 Inquisitive Kids. This video is all about mapping out rotations, which is lesson 4 of our chapter 10 of grade 8 math lessons. Here's our course outline for this chapter. We've already gone through 4 videos talking about translations, and we've just begun to learn about rotations. Our main learning goal for today is to be able to graph out basic rotations according to the properties of rotation. Here's some review. ABCDEF was translated to hexagon GHKLMN. And this is rotation. Draw line segment AB rotated 60 degrees clockwise around point A. So clockwise would be in this direction, and if you're going to use 60 degrees, you're going to get angle BAX. Remember, you still have to make a line segment that's the same length as AB. So that's why you have to plot another point, C, on the ray AX. Draw a quadrilateral ABCD with O as the center, and the rotation angle is 60 degrees. Just like translation, all you have to do is rotate or transform each point separately, and then connect the dots. We're first going to rotate A. Then we're going to rotate B. This is C prime. And then we're going to rotate D prime. Now, you can connect the dots to get this new quadrilateral. Now let's compare and contrast translation and rotation. What are its similarities and differences? That was translation, and this was rotation. Well, here are their similarities. They are both rigid transformations on the geometric plane, which means that after transforming, the shape and size of the original figure does not change, but the position changes. Here are the differences. In translation, you move in a straight line. In rotation, you either move clockwise or counterclockwise. For example, in translation, when you're saying the direction, you have to say from point O to point A, or towards point A, or something like that. And the measurement of movement is also different. So in translation, you move a certain amount of distance. And in rotation, all you have to do is measure the angle. Here's some practice. E is any point on side CD of square ABCD. If point A is the center of rotation, rotate triangle ADE clockwise by 90 degrees and draw the rotated figure. The key is to determine the corresponding point E prime of point E. Because if you rotate triangle ADE at 90 degrees, AD is actually going to overlap with AB. All you have to do is find where this E prime will be. It's probably going to be somewhere over here. So point A is the center of rotation in this case. Point A corresponds to point A. In a resulting triangle, A is still one of the vertices. In ABCD, AD equals AB. Angle DAB equals 90 degrees. So we're going to let point E correspond with point E prime. Therefore, these two triangles, triangle ADE and triangle ABE prime, are congruent, which means that angle ABE prime, equals 90 degrees, and BE prime equals DE. So these two sides are equal. Is there any other way to determine the correspondence between point E prime and point E? We can extend CB and draw an arc with point A as the center and AE as the radius to intersect CB at E. Connect AE prime to get triangle ABE prime as the rotated figure. What they're saying is they're going to extend CBE, and they're going to use one of those compasses, so one of those geometric tools, and they're going to measure the radius as AE and then start drawing an arc to try to get E prime. So this is what their graph roughly looks like. This would be E prime. This is, guys, I'm doing my best. And that's how they would get E prime. Then all you have to do is connect A with E prime to get the rotated figure. There are 3 elements of rotation. Whenever you're doing a problem, you have to determine it and confirm all of these elements. The first is the center of rotation. It's very important. Then the direction of rotation. Is it clockwise or counterclockwise? And then how much it's rotating by the angle. Where is the center of rotation in the figures above? Remember, a center of rotation can be either on the triangle, one of the vertices, or maybe even on the sides. It could be inside the triangle, or it could even be outside the triangle. Here's how you find it. Find the perpendicular bisectors of the line segments created by connecting corresponding points. The point where they intersect is the center of rotation. Let me explain this to you. So we're first going to find the line segments created by corresponding points. We're going to connect the corresponding points. For example, we have EB, FC, and DA. Now we're going to find the perpendicular bisectors. Remember, they have to be bisectors. So this is AD. This is EB's perpendicular bisector. And the perpendicular bisector of FC is here. So this is roughly the point where they all intersect is the center of rotation. How did pattern A transform into pattern B? First, we rotate figure 1, which is pattern A in this case, to about point A so that the pattern is straightened. Then we can translate figure 1 to point B along AB to get figure B. What are some other ways that you can transform this figure? You can also first translate this figure and then rotate it. The picture below consists of 4 parts, each of which includes 2 small plus signs. Can the red part be rotated to get the other 3 parts? Can it be translated, or can it be reflected? The direction of translation and the distances of translation are the 2 main elements we need to know in order to perform a translation. As you can see, if we're going to use translation, it's not going to work. Only these 2 will get covered. So the figure cannot be obtained by translation alone. Now we can use rotation. We need to determine the center of rotation, the rotation angle, and the direction of rotation. We can say that point O is our center of rotation. So when you rotate it, you're going to, yes, indeed, cover all these crosses. So all you had to do was rotate the 2 crosses about O 3 times. First is 90 degrees, then 180 degrees, then 270 degrees. Or you can use translation and rotation. First you translate, then you rotate. So after you translate, you're left with this figure, and then you have to rotate this entire figure by 90 degrees clockwise. We can also use symmetry and reflection. So we first reflect the 2 crosses on the left about EF to get this figure, and then we reflect it about GH to get the other side. How do you transform the smiley face on the right to the smiley face on the left? You can first rotate it, and then you can translate it. This is supposed to overlap. Take the center of the figure on the right as the center of rotation, and then rotate the figure by 90 degrees counterclockwise, and then translate to get the pattern on the left. You can also first move and then rotate. Class summary. Today we learned about how to graph rotations. We learned the steps to graphing rotation, and we learned about the 3 main elements. It's the center of rotation, the rotation direction, and the rotation angle. And we learned how to determine the center of rotation. You can find the perpendicular bisectors of the line segments created by connecting corresponding points. The point where they intersect is the center of rotation. I hope you enjoyed this video, and be sure to come back for our next lesson.